So maybe you've heard about the Arduino microcontroller, but you're not sure if it's for you or where to start with it. Then this video is for you. Hi, my name is Pierre and I'm going to help you to make sense of the Arduino microcontroller in this video. Let's first discuss what you will be able to do with this little microcontroller. Now, normal projects would involve sensing something and then maybe do some calculations or do some work with that and then have an output either to a screen or to a cloud server or to your cell phone or maybe to switch on something like a pump or a fan or a heater or anything that you want to control with data that you've got on the sensing side. So the microcontroller, the Arduino microcontroller, although small and although quite cheap, can be quite a powerful device that you can easily start using to do certain things around you and maybe to make the world around us a little bit better. Now you'll see on the Arduino board there's digital inputs and outputs. If you don't know what that is, don't worry about that. It's just inputs or outputs that you can use. There's also analog inputs where we can read an analog signal. There's a few power supply points, a 3.3 volt, a 5 volt, a ground that you can use in your project. Another question that comes up, am I not too young or too old to start with the Arduino? Now, I've helped some that's 9 and 10 years old, and I've helped a lot of persons over the age of 70 to work with the Arduino. So there's really not a limit. As long as you've got a basic understanding of stuff and you've got a PC that you can work with, then you should be okay. Now you may also ask, what type of background knowledge do you need in order to start with the Arduino? And I can tell you for sure you don't need a lot. You may ask, do I need programming experience? No, you don't need programming experience. What you do in the Arduino IDE is straightforward and you will easily pick that up. Also on the electronic side, what knowledge do you need there? You really do not need any prior knowledge of electronics. The stuff, the sensors that you use, the rest of the stuff, the control stuff, is easy to understand and straightforward. There's also a lot of examples on the internet available. It doesn't matter what you want to do. So you don't need a lot of experience. What you do need is access to a PC. And then what will happen is your little Arduino board will just plug into your PC with this cable. So the one end of the cable will plug into the Arduino board and the other end will plug into your USB port. The Arduino can also be powered from this USB port, so depending on the type of project that you're going to do, you may power it only from the USB port. So what will happen is, you will plug your PC in here, you'll program the little board, and then that program will stay on the board and it can run there continuously. You can either then permanently power it from the USB port, or you can just plug in a DC supply here and it can act separate from your PC in a location away from the PC. Now, I think the best way for you to see how this operates is for us to do a small project. And within the next few minutes, I'm going to take you through everything that's needed in order to do a project. The project that I've decided on is we're going to take a temperature sensor, small temperature sensor. We're going to couple that to our Arduino board, and then depending on the temperature, we're going to switch on, you can say a heater or a light or whatever you want to switch on. But we're quickly going to go through the process, and I'll show you exactly how easy it is to get started with the Arduino. And as soon as you've done 1 or 2 projects, you can go to more complex projects with it. So let's have a quick look at what we want to do. We will have our Arduino, and it's the Arduino UNO. We will read in the temperature, and that will be on port A1. We will then, depending on this temperature, switch on a LED. Now, the Arduino's got a built-in LED on pin number 13. So we're going to make that pin number 13 high. That will switch on the LED when it reaches a certain temperature. So let's say we set our temperature to 29 degrees Celsius. So as soon as it's above 29 degrees Celsius, the LED will be off, indicating that the heater is off. And if it's below 29 degrees Celsius, the LED will turn on, indicating that the heater will be turned on. Now, what we're going to do now, I'll show you the Arduino IDE. The IDE is just a place where you do your programming. The IDE you can find for free on the internet. So you can just go and search Arduino IDE. You can download it, install it on your PC, and you can start immediately with that. The code that I'm going to show you now is extremely easy to understand. You also don't need to write this code yourself. If you start with the Arduino, you can just take this code, you can change it and adapt it a little bit and get your first project going. So let's have a look at the code. This is the Arduino IDE, and I'm just going to go through the code, show you how easy it is to understand the code. Later on, you can make changes in the code and you can adapt the program to do what you want it to do. So we'll start with the code. If there's 2 forward slashes like that, it's just a comment. So I've got just a comment there. And then we start with the first part, where we define some of the variables. Now, the variable is just a place where you store some information in. And we're going to store the temperature in degrees Celsius in this temp C variable. And we're going to store the temperature in Fahrenheit in this temp F variable. Then you've got a setup part. Now, the setup part in Arduino program only runs once. And what we're going to do is we're going to write to the screen the values. So we need to establish the communication right there. Don't worry about that. This is standard in all your code. So you've got serial begin 9600. It's just the baud rate at which we communicate with the PC screen. And you don't have to worry about it. It's handled by the code itself. That serial communication is happening at that baud rate, so you don't have to worry about that at all. Then we say pin number 13 is going to be an output. Remember, we've said pin number 13 is also coupled to the LED, the little light on the Arduino board, and we want to switch that on and off, so it must be an output. Then we get into our main code. Now, our main code will do a few things. It will first get the temperature, and I'll show you that code just now. That code is also standard code that's written. You don't have to write it. Many of the sensors that you get, it's got standard code already. So you just call that function. You may adapt it a little bit to suit your needs, but you don't need to. At the start, when you start with the Arduino, you don't need to write this code yourself. So you say get temperature. That function, I'll show you the function, will go and get the temperature. Then if we've got the temperature, we want to switch on the heater. So we're going to decide at a certain temperature, we're going to switch the heater on, and at a certain temperature, we're going to switch the heater off. And the light, in this case, the LED light, will be an indication of that heater. Then we're just going to print to the screen, and we will see it down here just now. We're going to serial print temperature in Celsius and then the value that's stored in that variable. Remember, we've said temp C, that's where we're going to put the temperature in degrees Celsius. So, and then we're going to serial print temperature. This is just the wording on the screen, temperature in Fahrenheit. And we're then going to print the temperature in Fahrenheit next to that. Then we're going to delay for 2000 milliseconds. So that's 2 seconds. It's just delayed 2 seconds. So you can agree with me, everything here is quite understandable. Yes, there's certain structure in the code, and you will get used to that as you go along. But this is easy, and you can straightforward read the code. So, all right, now let's have a look at the two functions that we've called, the get temperature and the heater. And let's start with the get temperature. Now you'll see if I go down in the code, here's the get temperature function. It's called from that main loop. And this is a standard code that you copy for that specific sensor, so you don't have to worry about this at all at this moment. The sensor that we use is a 10K thermistor. So it's a very easy type of sensor where the resistance changes according to the temperature. Again, not something that you need to worry about at this stage. So, and then let's go to the heater function. The heater function, we say, if the temperature, now see how logical this is and how easy it is to adapt this. If the temperature C is smaller than 29 degrees Celsius, then we do this part. Else, we do that part there. So if the temperature in degrees Celsius is smaller than 29, then we're going to print to the screen heater on, and we're also going to switch on the LED on pin 13. If it's not lower than 29 degrees Celsius, in other case else, we're going to print to the screen heater off, and we're going to put that LED off. We're going to write a load to it, so to switch it off. Now the same way we're switching an LED on and off now, we can also switch a relay on and off. Now you get different types of relays, and I'll show you the different types of relays. And with those relays, you can then switch on a physical heater or a pump or something that you want to switch. So the relays, very handy devices. They come standard for the Arduino, so you don't have to assemble a circuit, or you just plug it into the Arduino and you switch that pump or that heater or whatever you want to switch on and off. In our case, we're just going to switch the LED on and off so that you can get a feel for this. Alright, so now you've got your code. So if you've got your IDE, you downloaded your IDE, you just take my code as it is. I'll give it to you. The link is in the description always. And you just take that code, you paste it in there, and then you say compile. Here on the left hand side at the top, you'll see there's a place where you compile, and you'll see compilation complete, no errors there, so it compiled correctly. The next thing that we're going to do, we're going to upload this to our Arduino board, and I'll show you. Let me just switch my bench on as well. So we're now going to upload that code to the board itself. But before we do that, I just want to show you how we're going to build the circuit on the board quickly. Let me show you the circuit. So the circuit will, of course, have our thermistor in it, and our thermistor will also be coupled to a 10K resistor, and this is just the going down to ground. So that's just the negative part on the Arduino, and that part there is going to VCC, which is actually just the 5 volt on the Arduino itself. Then from this point here, we go to the Arduino board. Remember, we've said we're going to use pin number A1, so that will couple directly to A1, and then we're going to switch on the LED on pin number 13. So that's how easy the circuit is. Let's build the circuit on the board itself. So let's start with our 10K resistor, and you see this is a breadboard. It's very easy to use. In a separate video I'll talk a little bit about the breadboard, but it will just make it for you easier to build a quick circuit. So we'll put in our resistor there. Then I'll take a wire from the resistor. Remember, we've said from that resistor down to ground. Let's take a black wire. down to ground, and you'll see there's a ground pin on your Arduino, so you just push that in. Use these little jumper wires, very handy to use in this case. Then from the other part of the resistor, other leg of the resistor, we go to A1 on the Arduino, so you just check it's numbered there and you go to A1 on the Arduino. So the next thing is our thermistor. We can just put the one leg of the thermistor next to the resistor, and the other leg of the thermistor we can put on VCC, which is our 5 volt. So we can just couple that 5 volt to the 5 volt on the Arduino board. There we go. So there we've got it. We've built our circuit. It's quick and easy. Our thermistor, where we're going to read the temperature, there's it. And then also you'll see there is pin number 13, and you can see that there is an LED there on pin number 13. So our next step now is we're going to upload this program to the Arduino board. And you can see I've just plugged the Arduino board into my USB port on the PC. And here at the top you'll see there's the place where you just upload it. Just one thing that you must make sure is under tools, you must just check that it's the correct board. In this case you can see the Mega is selected. This is not a Mega. So we must just go to the boards and we can just go and search for the UNO. So it's the UNO, that's correct. And then we just check our port, and there you can see the UNO is connected to that COM port. And now we're ready to send this code to the Arduino. And we do it by pressing that button, and you'll see there's it uploaded already. And now we can open our serial monitor. You can just press here, and you'll see there's the serial monitor communicating with the Arduino at the moment. And you can see the heater is on. Why is the heater on? Because the temperature that we read is 22.08 degrees Celsius, 22 degrees Celsius. So we suspect our heater is on. Why? Because if we go and check here with the heater, we say the heater must be on if the temperature is lower than 29 degrees Celsius. And if it's higher than 29 degrees Celsius, we will switch off that light. If we now go to the bench, you'll find, and you can see that the LED is on at the moment. There's the LED and it's on at the moment. Right, what I'm going to do now, I'm going to touch with my hand the temperature sensor, and we will look at the temperature here as it rises, and we can see if it goes above 29, then the heater should switch off. So that LED should switch off as well. If you look carefully there, you can see the LED on the bench as well. So I'll just take the sensor in my hand, and you'll see I will just touch it, and now we can check the temperature. Check, there's it going 23, 24, 25, 26, 27, and we're waiting for it to get to 29 so that the heater must switch off. Still 28, there's a 29, and you can immediately there you can see the heater is off now. If you look at that LED on the Arduino, you will see that that is off as well. So if I take this sensor out of my hand, you'll see that the temperature will slowly drop again. And as soon as that temperature goes below 29 degrees, it's 29.8 at the moment, 29.6, 5. As soon as it goes below 29, then that heater will switch on. There you can see it, 28.97, and the heater is on. Guys, this is how easy it is to get something going with the Arduino. All that I've done is I took an Arduino, I took a USB cable, I plugged it into my PC, I've coupled that small circuit, and I've uploaded the code, and there's it running. Now this is a very simple project, and you can go very complex and quickly to that level with the Arduino. If your time is valuable, you don't want to waste a lot of time jumping from this to that, let me help you. I've got some courses on the Arduino where I take you step by step, teach you everything that you need to know, but not a lot of stuff that you don't need to know. And then you can easily do a lot of things around your home with the Arduino microcontroller. The link to the website is in the description. Go and have a look and see if that maybe can help you. Another thing is there, you'll see there's a WhatsApp button there. Please send me a WhatsApp. I will answer myself. Just take into account that the time difference in some cases is maybe 10 to 12 hours. So if I answer a little bit late, it will be just when I wake up in the morning or so. But I'll answer you on the WhatsApp, and if you want to communicate with me there, and we see in what way I can possibly help you to get going with the Arduino. Thank you for watching the video, and I'll see you in the next one. Thank you and bye-bye.